So what we're going to talk about today is multiplying and dividing with our radicals, okay? So when we are multiplying and dividing, whatever is underneath the radical multiplies underneath the radical. Whatever is outside of the radical multiplies outside of the radical, okay? Whatever you do, please make sure you reduce your final answer. So, could somebody please tell me, are 5 and 35 both under a radical? Yes, and we are multiplying, which means 5 times 35, we're going to multiply it and keep it under the radical. What's 5 times 35? 175. Okay, well, I know, okay, you can do this one of two ways, okay? Some of you like to do this, okay? Well, this is the way that we talked about yesterday. 175 means 25 times 7. What's the square root of 25? So we have 5 square root 7. Okay. If you really, really love the tree method, we know 175 is 5 times 35. And 35 is 5 times 7. So 5 squared underneath the radical comes out as 5, and 7 stays underneath. I am fine with whichever method you would like to choose. This, to me, I think is going to help you more when you get to Algebra 2. But whatever works for you, you go for it. Okay. Now, I want you to look at this one right here. We have numbers outside and inside the radical. So what we are going to do is we are going to take 2 and 3. They are outside the radical, so we are going to multiply them outside the radical. However, 8 and 7 are underneath the radical, so we are going to multiply them and keep them underneath the radical. So I would not, because you might just create more, you might have to simplify more later. So you can, but I think you might as well just multiply them and then simplify.
And once you multiply them, you simplify down.
Yep. So we know that 56 is 4 times 14, right? Okay. So since we know that the square root of 4 is 2, if we write the square root of 56 as 2 square root 14, so this becomes 12 square root 14. So we multiply outside together, we multiply inside together. Mm-hmm. Locations. Okay, now go to the next page. Okay. So division works the same way, where if you have division with radicals, you can do that and keep it underneath the radical. Okay, that is an option. Okay, no matter what though, we cannot leave a square root in the denominator. So there's a couple different ways to go about this problem. Okay, but this is what I see. I see that there's a square root of 10 in the denominator. We cannot have a square root in the denominator. So to get rid of a square root in the denominator, we are going to multiply by, does anybody remember? No. We are going to multiply by the square root of 10 to both numerator and denominator. First of all, we're really multiplying by 1. Do you see that? Radical 10 over radical 10 is 1. We're multiplying by 1, so we're not changing the value of our fraction. Okay. However, what does this accomplish? What is the square root of 10 times the square root of 10? Square root of 100, which is 10. And now I have the square root of 50 in the numerator. We have now gotten rid of the square root in our denominator. But is it simplified? No, because 50 is what, Harvey? And the square root of 25 is 5. So we have 5 square root of 2. Is that simplified? It's not simplified. Because, Harvey, outside of our radical, we have 5 over 10. Which is 1 over 2.
Wait, how do you put a one? You want to put a one? There's something there. Can you say something?
Oh, yeah, you can put a 1 there. That's not a problem. So do you see the 1/2 from the 5/10? Now, there doesn't have to be a 1 there. We don't have to write it, but it is there. Okay, so if you write it, cool. If you don't, also cool. Okay. It seems harder. Well, this is why we saved it for today. Okay. Now, I will tell you, it would also be legal if we took the square root of 5 over the square root of 10 and we called it the square root of 5 over 10. When what's 5 over 10? 1/2. Okay. Then we could go into, okay, I can't have the square root of 2 in the denominator. Okay. Is one way faster than the other? I don't know. Okay. I'm showing you this so you know, like, technically you can do that, but I would prefer that we just get rid of the square root in the denominator right away and then simplify from there. Okay. So this is what I want you to do. I want you to go back to your whiteboard from yesterday with your same groups. And I want to see these 3 get simplified. I know that you see them on your notebook right now. We'll come back together and talk through them and write them down in our notebook. But I want you and your group to try it out first. Okay. So let's talk about, it looks like the first one went okay because we multiplied the 5 and 4 to get 20. We multiplied the 7 and 12 to get 84. And then we broke up the 84 to be 4 times 21. Since the square root of 4 is 2, 20 times 2 is 40. So we have 40 square root 21. And that looks like what everybody got. So I want to make sure that you have this written down the correct way. Now, when I look around the room, it looks like we're okay with the second one too. It looks like we multiplied both numerator and denominator by square root of 7. So we have the square root of 42 over 7. And there is nothing else we can do because 42 is 2 times 21. So 2 times 3 times 7, none of those are perfect squares. So we are stuck. All right, number 3, we had some trouble with. That's okay. Let's talk through it. Okay. It looks like we all wanted to multiply square root of 12 to numerator and denominator, and I think that that's a great idea. Here's where we had some trouble. Is 3 underneath the radical? No. So when we multiply 3 times square root of 12, we have 3 square root of 12. We can't squish those together because 3 is not under the radical. If it was square root of 3, then we could say square root of 36. Okay. What's in our denominator? Okay. I was like, I don't know where 7 came from, Alexa. Okay. Now, we know that the square root of 12 is not simplified because 12 is 4 times 3. Okay. So since the square root of 4 is 2, we can call this 4 squared of 3. Oh no, I wrote that as of 2. So this is a 3, 4 times 2 is 6. Thank you for helping me out there. Sometimes talking and writing at the same time doesn't go as well for me. Okay. I wrote 2 instead of 3. I'm sorry about that, Harvey. Harvey, can we reduce this any further?
No.
Okay, so we have the square root of 3 over 2.
Yeah.
Okay, so we had a couple groups get kind of an issue with the multiplying. That's okay. We're going to practice it. Okay. So good news. Turn the page to page 10. You only have 1 page of a homework assignment.
Oh,
It's still 22 questions, but it's only 1 page. And it's 11:15 and you can get started.